Hello, everyone. Thank you for coming. So, what I'm going to present is work I've done with mainly like two co-conspirators at work. So I think the mic's too loud right now. Thank you. I can get closer to it, but always. Thank you. So it's Evan Tabor, who's another like system engineer, software developer at work, and Barry Clark, who's very versed in robotics. So together, what we did is something a little bit different from a lot of what you've seen here. So we're like, okay, cool. So Temporal, it's neat. You can orchestrate a bunch of stuff, and typically you do it in a cloud setting. And we're like, well, we got orchestration problems, but in a factory, and it looks like it could just do the job because we got a bunch of APIs everywhere. And that's what the talk is about, is bringing Temporal in the factory, like on-prem, and doing manufacturing orchestrated with it. So yeah, we work at Bright Machines. So this is a good example of what we do. This is what you find on our website, is we deliver a solution end-to-end. So we bid on automation problems where what we deliver, so the white parts is what you need to get the job done, is like enter product into the assembly chain and exit product from the assembly chain, potentially with an inspection station at the end. The real thing that gets us successful is those black boxes in the middle. Looks like big fridges. We call them BRCs, like bright robotic cells, and that's where the assembly steps take place. And what we deliver is the end-to-end solution, like the hardware, the software, and also the end-of-arm tools that enable the automation for the manufacturing process. So that's what we do. And a big thing also is like giving you like data on what happened during the assembly and making it visible. So make it more concrete. This is Dem Insertion on the server. So this is kind of like our killer app right now. So what you see there is like that robotic arm is going to go back. It's going to grab a DIM from the DIM tray, and it's going to bring it back, insert it into the motherboard after scanning it. And so that lets us like record like which DIM goes where. It's always inserted with the same force. The board is inspected with computer vision to make sure like a previous step did not leave like the cables laying around, because otherwise that robotic arm has the force to chop the cables. And so that's currently our killer app. It is our killer app because the number one source of defects for server assembly is actually Dem Insertion. That process is a process, like if you see people doing it in a factory, they got like some custom molded like plastic things to push on them. And it's, they probably get RSI over time. Like it's just bad. And so we automate that. There's other people doing it. The reason like we're pretty successful is because we got more flexibility in the automation. So you start seeing what we're like, well, Temporal. Because I'll get to it later, but it's been hard for us. Like we started by writing our own orchestrator. So I'll cover that in a little bit. The main thing is, this is our killer app, but it's just having flexible orchestration is really what differentiates us. And so now, for instance, we're moving to CPU, heat sinks. We got other applications for battery assemblies, for like the battery modules you get in EVs. So we're doing a bunch of things. Now, so continuing with just this example to see like what it looks like for us. So in that video, it just looks cool. Okay, it's big place, essentially. But you got to, in that robotic cell, you have a whole part that's real-time controlled. So first, like, the conveyor, right? You got to bring that server in. Then you got all the tray feeder. Like the trays, actually, there's a whole magazine of trays behind. And so you got to, move them, scan them, and know what you're putting in there. All that is real-time control, including the robot controller and the end-of-arm tool. The end-of-arm tool, depending on how you do it, you can decide to control it directly, or you can, if you buy some software package from the robotic arm manufacturer, then you control it through the robot, so you can offload the control there. The part where we have our orchestrator is actually at the bottom part, like where we define the assembly process. And so that runs on a non-realtime system. And essentially we rely on the real-time system to do all the safety stops, because you got to stop real time, otherwise like the robot like hits the wall, then you damage your expensive end of arm tool, or or you damage the motherboard. All of that costs a lot of money. So then the bottom part is more like what we discussed in most of the talks here. It's like, yeah, you call the scanner, it's over HTTP. Like, did you see the barcode on the DIMM? That's pretty easy. And so, but to orchestrate all that is what we have to do. So how did we get with this idea of like putting, because, oh yeah, sorry, that was Temporal Light orchestrating the Dem Insertion. So the first full disclosure, like once upon a time, I did work on the great-great-grandfather of Temporal, because I worked with Max and Samar at AWS on Simple Workflow. So that's why I have that bug, I gotta admit. And the moment I joined that company, I was like, there's gotta be a way to simplify things, because we have message queues like everywhere, and they're hard to debug. They have all the, I don't need, there's enough talks covering that. It's just, it causes a lot of problems that you have much less of them if you use something like Temporal. So first we were looking at the line level workflows, and like, yeah, that sounds cool. We could do stuff. We could get like the idea of like end-to-end process time, a bunch of things. Because one of the things, like when you got those assembly lines, there's people on the line, they're gonna grab a server and pull it out of the line, do some manual, they might never bring it back. You would like to know about that, for instance. So that was the original idea. But that wasn't really getting much traction. And then everything became very clear when I saw Temporal Light come up. I was like, okay, no, that makes sense. We can fit it into a robotic cell, and we can start working with that. And so that's how we started. First I did a mock and go, showed it to everyone that would listen to me at an internal company workshop. And they're like, well, that's cool, that's Go, but we don't want to do Go. I'm like, okay, but I don't necessarily want to do Java either. And it turns out anyway, we should get out of that, because our systems guys, they do Python. So started mocking in Python. And what you saw is actually this Python code running behind the scenes. So, but it's taking a step back, so it really resonated the keynote this morning, because like a key thing that we're doing here is separating the accidental complexity versus the essential complexity. So in our case, like the essential complexity is we got to do the orchestration, we got to do the manufacturing process. The accidental complexity is everything that we implemented to solve that we don't necessarily need. And so, digging in there, we really need to orchestrate. And some parts are real time, because otherwise it's going to cost us a lot of money to be wrong, to have like a long garbage collection, for instance. And essentially, we got a first mover disadvantage, because we started by writing our orchestrator. And honestly, if we didn't have it, we wouldn't have fundraised, we wouldn't exist. Like the first contract we landed are all based on we built our own orchestrator. But if you dig into it, there's also the startup story. It's like we did our own language for the orchestrator, because that's what you do when you write your orchestrator. Like everybody ends up there one way or the other. And to make it a little bit harder, we made our own visual programming language, because there's this idea that we're going to do it low code or no code, and it turns out we're probably going to go back to it, but right now that's not what we need. And so it's actually getting in the way. We just have still a lot of stuff to implement if we want to do more complex processes. So that's adding complexity. What people mentioned earlier, you do your own orchestrator, then you have to do your whole observability stack. Well, again, maybe you don't need to. And then because everything was making HTTP calls everywhere, then okay, well, guess what? You're going to mock HTTP requests. And so all that, actually, we switched to Temporal. Well, we use Temporal. We don't have our own orchestrator. We don't have our own language anymore. We use Temporal SDK. So since we picked Python, we use the Python SDK. By the way, sorry, it's a little bit text heavy. I don't have cute pictures to explain that. I thought about it and I couldn't come up with them. So apologies for that. But back to the main thing. For the UI, essentially it's what's been discussed today. You can do workflow queries. And essentially in our case, you can say, oh, look, I inserted 8 of the 24 DIMMs. Well, you're 8 out of 24. You can do percentage, you can do a wheel, but like, that's the status of the assembly. And so that's it. And then for the observability stack, well, we got the metrics from the SDK. We can do standard JSON logging and look at it in low-key, like all the normal stuff. One of the cool things is product genealogy. So internally, it's been discussed a lot, like traceability, but it's more like how did this thing come to be? So for the motherboards, we want to know, like in each slot, it'd be cool. Like you can't do it from a manual process, but you can totally do it when it's automated. You can get the exact barcode of every DIM that's in every slot. And if you got any defect after, bam, you can pinpoint it. And you can also record when you insert the DIM, what's the pressure? So then you can fine tune also those parameters of insertion force to reduce the defects and drive more nines in the reliability, the yield of the first pass yield of the manufacturing. And then, yeah, for mocking, well, just put mock activities. I mean, that's it, like just what you would do with Temporal. So essentially, then we have more time to work on our customers and make them happy. And one of the big things is, how fast can we go from a bid to actually a prototype to show our customers that, hey, we can take on that job. And so here that lets us go a lot faster to get to the POC. That lets us also go faster to get to what's called, in our domain, like the factory acceptance test. So that's like your customer comes and looks in your factory, like where you assemble, the factory where you assemble the micro factory, right? It's like factories all the way. So they come and they look at it and they're like, oh yeah, that's gonna meet what we want. And yeah, clearly you're doing the cycle time we want. So we can get to all that faster. Because also again, like we just look at the workflows easier. So the next thing is just to put more context on the fun part, like, it's robots. I don't have lasers, maybe that's next year, but I do have a big e-stop button on my robots. And that one yields to a really good conversation with temporal product management or internal actors, so what we do. Because the e-stop, the goal is, if you look at it from the most like paranoid ways, someone's about to get hurt, hit it, and nobody gets hurt, right? Because the rest is hardware at the end of the day. And so, but for us, the main use case besides that is developing, in development mode, you got an essential automation engineer that's facing the cell. And I just love the description from my colleagues, like 2 hands on the keyboard and 1 foot on the e-stop. And it's not a joke because they're all connected. There's several e-stops around the robot. So you got this thing called a teach pendant. This is how you control the robot. And it's on a long cable so you can move around and, make it move a little bit, like kind of like the claws, when you try to get the plushies. So you can control it, right? And so that one's on a long cable, so you can literally put out your foot and literally code like 2 hands on the keyboard and a foot on that thing. People do that. The production case is more where you push it, it's assembling stuff, and you just want it to stop temporarily to look at the process. The assembly, if you looked at it, it's about 10 seconds per DIM, right? If you got 24 to put, like, hello, that's 4 minutes right there. If your bug is because you got a vision problem and the placement towards the end is not just right, when you press that e-stop, if you lose state, it's really painful to just start over and see if it's going to crash. That's for the dev mode. In production, if you interrupt it and you can't resume, then the only thing you can do is flush the product, and then it goes to manual QA and rework, where the yield is lower, it costs a lot more, you lose a lot of the automation benefits, because in production, we're not allowed to insert a DIM twice. It's like one shot, get it working, that's it. So what's cool with Temporal is we have that state. So when we press the e-stop, what we do is we just stop the workers, like right there, just kill the processes, and wait. And then when you pull the e-stop back, we'll restart. So we don't accumulate a long retry history. We're like, no, we don't aggressively retry. We're just going to resume once you pull the e-stop. So that works good. I mean, we had the first demo of that was accidental. We're trying to record a video to show progress. And one of my co-conspirators is in Texas. I'm back in Seattle, and we're working with someone that's at the headquarters, thank you, in San Francisco. And he's got to go to a meeting. So he pulls the e-stop. He pushes the e-stop because that's the right thing to do, stop the robot. Goes to a meeting, comes back from the meeting, we get back on Zoom, and we record the video. And it's resumed from exactly where it was. Now, real life, like that's dev mode. Real life, we want to do more inspection, and we got the computer vision capabilities for that. From that, we could almost also potentially like pick a board back in, look at its state, and potentially resume synthesize the state of the workflow and resume from there. If we got, or pick up an old trace and like do a splice. That's also a cool thing we can do. Another good advantage is this. Not much, right? You just do workflow trace. But that makes our systems engineer really happy because that means you don't have to go to ELK. Because we got all those rabbit MQs everywhere, like sending all the messages for everything that happened. And well, then, that's all tiny like sausage slices. And if you want to look at the whole thing, you need ELK. With this, we don't. It tells you exactly when it happened. You can go look at the logs. You know where they are. You know which robot for at what time. So it's pretty cool. It's just neat what we get out of the box that way. This is a screenshot. Like that was an example workflow. Actually, I don't have a real one, but that's from our dev environment. It's pretty comfy. The other advantage is this. If we just open it, also updates as the workflow runs, and really cool. We get all that. We write nothing. We just write our process. That's the cool thing for us. So that was mocking like something happening in a robotic cell. We're going to look at doing at the line level, and it's the same thing. You want to know where that product is, and you're going to see it. You just unfold. But not breaking new ground, not pretending I'm breaking new ground, just saying, well, we're happy with it. So recap. We went from having a low-code, no-code recipe editor and a homebrew orchestrator. And now we've got, currently we've got cells in dev mode where our system engineer can have just one robotic cells. They don't need something in the corner, just like iterate right there. They have temporal light on it and they're happy. Like they don't need to, we're starting to onboard. It's looking pretty good. Like it's actually happening this week. Not planned, but it's happening and no complaints so far. The recipes are code. We have precise metrics with percentiles, which we didn't have before. And we have very clean semantics for retry. And so the next step, really what we're working on is we're gonna have to do a temporal server on-prem on the side of the line so that we can do line level workflows. And really cool. We onboard people, we point them to temporal.io, we say, look, people are nice on Slack, go there, there's the forum, there's Stack Overflow, and it's really cool. Knowledge transfer is easy. So some fun facts of this project is, got really awesome support on Slack. Really, thank you. That was super cool. So because we were early on Temporal, so I remember there was a disclaimer don't use that for production. So I went hey Jacob, sounds like it's you the offer. What is it bad? Nah, this is the little caveats. Okay, we're good. Then once we started, when I was doing my demos, I needed to do just show people look, this is the visibility we get. But there's the repo with all the dashboards. So I just took that. It worked great. Out of the box, did nothing. Got all the credit, did nothing. Sorry, I said I used it from the repo. The one thing was when we started using the Python SDK, there was something we started that's when we got the green light to start implementing, and we wanted precise numbers because we're there's the whole thing, you do demos, you talk, whatever. Then you said, no, we're really gonna automate that way. It better work. So we did a lot of benchmarking. And at the beginning, we had really goofy numbers. That doesn't make sense. So first, it looks like it's a couple other magnitudes off, but something still wasn't right. So, well, Chad, also on Slack, it's we confirmed that eventually we zoomed on. Just so you know, the Python SDK is based on the core SDK, so it reports in milliseconds. So therefore, the base dashboard from GitHub are off by 3 orders of magnitude. But then we're it's still goofy. Oh yeah, well, the default percentile buckets are also not the best for at least our use case. So you got to tweak them, and then I don't know where it is, not know if it's exposed or not. But what's awesome is got all the support that I needed to just tweak the dashboards, rebuild a branch of the SDK with the percentiles that we need, because we don't have the normal bandwidth of a cloud use case. For us, a cycle time of 10 seconds is cool. So that means a whole workflow every 10 seconds per robotic cells. It's really nothing compared to most of what your systems do here, but for us it's good. It's good because then we don't have to own all the rest of the code. And so, yeah, what we got is so after that, we're still working at figuring out how to enable archival for the temporal dev server, because just for support for the system engineers, so we can look back. If it takes more than a month, we probably still want to be able to look at them, but that's minor. The recipe development, so when we really started hacking, okay, we're going to do Dem Insertion, it took 2 days to just like make it work. It took more before. And then to harden the version and work around bugs we had, because we're using different code path, because we know orchestrating exactly the same way, like there's some coupling we didn't know, whatever. You always find out when you change a little bit. Took 2 weeks. That was our first pass. So for us, it's awesome, like the velocity we get with this. And so we got a new high-risk project that we're most likely going to prototype that way, because look, yeah, we can go fast. So that's neat. And yeah, performance stability, like seriously, like we compare like our homebrew and tune the orchestrator and the temporal light. We can't really tell a significant difference. Actually, there tends to be a more precise performance bending by temporal light than what we do, for whatever it's worth. I mean. So yeah, so future work, we're gonna think outside the cell, you know, like do line level workflows. So the classic one is just define, okay, well, now we're starting to do like CPU insertion and heatsink screwing. You just say, well, you ought to also do that. But then you track it as a workflow, so then you can really have the genealogy for the whole board through the line, as opposed to the board through one robotic cell. And another example of line level workflows is just the work orders, right? So there's many different things, like there's fixed batch. So it's like, make me 100 of those widgets. The problem is there's always some errors, like at some point. You know, nobody's perfect, neither the material nor us, unfortunately. So then you got the last one. So I'm jumping from first to last for those bullets, but this fixed batch with, no, actually I really want to make 100. Here's extra material you can use if you had some problems. And the really like the on-demand one, like the golden grail, is like everything that comes is a custom order and we can do it. That's called rolling changeover. So we're looking at how we're going to support those things. So to stick with the format, I like to recap as I go, but here's the key takeaway slide. Of course, no, for sure, it helps. And it forces me also to think, okay, so what are all the things that I presented? So we really reduce the accident complexity tremendously. Like at this point, I don't know what we could remove and still have the system do what it does. And we gain many new properties, because what we haven't tapped into yet is you get a bug report from the field. What we're going to be able to do is, okay, cool, send us the workflow history. And then you can replay it offsite in the debugger, step through it. Sounds normal, but that's cool for us. Like, it's not something we had. So that's huge. And systematic metrics also, yeah, like that's better than what we had. And the data retention with archival, once we put a full-fledged temporal server, that's really cool also, because it's one thing that we don't have to build. Oh, sorry, that we don't have to build. Thank you for that. One good side effect is there was this whole, like, you know, is your language better than mine or whatever. By the way, IEEE just published the ranking. Python is #1. So if you have those battles, just saying, like, that's like one of the big authorities. I don't like those battles. For us, it was more, what is demonstrably the easiest to bring on board system engineers that were using our low-code, no-code, and they're effectively programming when you see what they're debugging. So Python is the right answer. And that's also helping us rethink some of our interactions. So there's conversations like, so what does it mean not to initialize the robotic cell? And clearly it's a workflow, so we're going to get there. But it's not a workflow just yet. In the product genealogy, I mentioned it, like, this is just, you keep track of what your workflow is doing. You got that array of, like, I inserted this dim in that slot. Cool, that's it. So, yeah, that's what we got. And yeah, thank you. This is the really, if you want to talk to us, we got a page for that. Like, contact us. Feel free if you need automation, if you want to work on automation. Yeah, thank you. I'll take questions.
Woo, thank you.